Welcome everyone for joining us today. So we will discuss today about accelerating the development with AI in Sensa team. So in this presentation, we will cover a pilot project, Sensa Data Explorer, and how we accelerate the development by AI. And by this development journey, we will share our experience and some tips we are interested about the follow development by AI. And our final thoughts after completing this journey, we will share at the end as conclusion. So let's first talk about the Sensa Data Explorer. So when we were at client onboarding at Norway, then our client has a vague requirement about a project which is Sensa Data Explorer. So by this project, the opportunity will be actually exploring the time series data, which is stored in a time series database. User will be able to explore their data schema and the data itself by this portal. There will be some other portions of this project, which is knowledge graph, to relate the data with the real world phenomena. And also there will be a LLM chat based advanced query so that some user can ask a question in natural language, and our portal will be able to provide the answer by gathering the information from knowledge graph and attaching with the data from the database. And there is another advanced part, which is creating virtual data by manipulating the data by calculating some values, some rows. There will be some new data which will be created by the user. So as we have a very vague requirement, then we got 1 hour of time to show something about the prototyping, how it looks like, this type of things. So at first we use Google Stitch, which is a alternative of Figma, so that AI can generate a sketch for us. So let's quickly show that sketch. So this is the sketch we have generated by doing only 2 chats within 5 minutes. So it was likely this one. There will be some database selector, which is called bucket in time series database, and the measurement, which is actually a table in relational database. And there will be some option to write some query. To run the query, it will show the results. And there is some math operations. We are calling it virtual data by manipulating the rows and the columns here. So actually, the final output, it was like similar, which was designed by Stitch here. And then we were trying to build a software like this so that user can or our client can explore a bit as a prototype. So we use lovable.dev. So here is our output, so that we actually similarly copying the design from this and implemented here. So you can select the buckets and the measurements, that you can write some query and execution of query. There is some data here, there is charts. So it's a quick prototype, the transformations. So it took only 20 minutes by few chats. And the another thing here is you can edit virtually, like this portion of header color or the organization you are not interested about, then you can just select by visual selection, and you can just remove this part or modify this part in this specific portion. You can do it. So it's very good for prototyping. It just takes 20 minutes. And the Stitch and the Lovable, these two combined, it takes only 30 minutes to give a presentation to client to visualize their thoughts into real applications. And then we actually tried to add some task in Jira. So here is our Jira. So here we added some epic and tasks about that projects, and we build a robo agent so that the description we can write automatically, because writing a description of a task is boring. So our AI agent can do it for us. So if I just ask a robo agent, here is our agent, Sensa task descriptor. So if we click here and write, our task is update metadata for data node. So let me give an instruction. I want sorry, slash, yeah. So I'm selecting the descriptor, and here I have to write, I want name, GUID, and description in data node. So here is my online requirements, and AI is writing in this specific format. In Sensa team, we have decided that our task descriptor has a format like summary, which is a summary like this, and the description, what we are trying to do, why we will do this task, and how we will do this task, and the DOD. So all are written by AI. So we can just insert and do some modifications if I want, and then it's done. So it's like 30 seconds job to add a descriptions. And then when we try to develop this project as a production grade, then we try to bold and data button these two platforms if we can do this real development by these platforms. But actually we are failed to do it because bolt and data button, these two platforms and other available platforms who give the opportunity to develop a project in for production, the issue is they are limited with the tech stacks. Like in the data button, we are trying to do some selecting a tech stack like Django for backend, but it's not possible. They are limited with the fast APIs, and Bolt is the same thing. And for the front end frameworks, we are limited with their frameworks. And another problem is if we want to collaborate multiple developers in on projects, it's very challenging by maintaining these platforms. So we finally move into our cursor. We have ideally chosen the cursor for developing the AI, our project by AI agents. Besides cursor, we have selected ChatGPT and June, PyCharts June, other tools. So my teammate Hassan will share his experience with these tools and the real development flow.
Thanks, Asmat bhai. Can you stop?
Yeah, I'm stopping.
Okay. So hello everyone, I'm Hassan, working on Team Sensa as primarily as a lead content engineer. And when I joined the team where Hasnat bhai left off, my task was to actually scope this out, that if the total front-end development can be done using the online app builder platforms that Hasnat bhai shared, or something if we need to go into our traditional way of development, but keeping in loop the AI assisted development always in the setup. So what we figured out was that instead of before even writing a single line of code, our first target was to set up the ecosystem so that it will be always adaptive to AI assisted development. So what we did first was keeping in mind that there are several options out there. None of them are perfect yet. Cursor has a very good agent. There are other primary development tools like IntelliJ, and Windsurf also came lately, but none of them are able to do something completely perfectly. So we laid out our project so that it will be applicable to all of the available tools out there, at least whatever is primarily used in our team. For front-end, it was IntelliJ WebStorm from my side, and also Cursor. So what we did was first created a layout of the setup of AI and giving it in, which are called rules and ignore files or guidelines in some terminology. What it does is we created a project, a boilerplate project for this demonstration, and let me go through this quickly. What we did was, first of all, created a basic blank layout without writing any project specific code like a Next.js or any other whatever we needed. But first we created the rules that were required by Cursor. And most of the time the rules file give a context to whatever we want the AI agents chatbots to do. Like for example, in our front-end Next.js project, we wanted the role of a front-end engineer, and we provided the details of the coding environment and what are the styles that it needs to follow. And from a Cursor perspective, these are Cursor rules. From a Cursor perspective, you can add it to your project from Cursor settings, rules, and commands. And this is the add rule button that you can add. And when you are adding a rule, you can see that this special markdown comment is here. And these are Cursor rules settings, which allows you to specify whether you want this rule to be applied for all of your chat commands, chat actions, or you want to apply it manually. At that point, you have to specify the rule by saying at the rate rules in the chat commands. Also, you can apply to specific files, at which point you need to provide glob, which are called file patterns. And also you can apply intelligently, and you leave it to the agent themselves to decide what to do. So these are Cursor rules. You can, and also the similar thing is available for IntelliJ, which are called the AI assistant rules. IntelliJ's primary coding agent is the AI assistant, and the other tool is called Juni, and Juni also follows the same rules file if specified. Otherwise, you can also give it a guidelines file, and this is also the more or less the same thing that we specify in the rules. So these are the initial setup that we have. And the same goes for Windsurf. Windsurf is a fork of Cursor, so you can migrate the rules directly from Cursor to Windsurf. And if you are using Claude Claude code as your primary agent, you can also specify this Claude.md file, which are the rules files. So you can find out more of the details of this from, say, for example, if you use a Cursor, in Cursor's official documentation, you can find the rules, how the rules are created, and what are the meaning for the different options. And one thing about rules in Cursor is that, say, for example, you can specify exactly to the file up to which you want to apply this rule. So you can create a rule and just specify the specific file name if you're not using globs. Specific file name for you want this rule to apply. So Cursor gives you that nitty-gritty control details. I have not worked out if all the other agents support this, but probably they will. And as for the ignore files, this is the thing that you want the brain to ignore when you are providing the context. Cursor ignore and AI ignore from brain's perspective, they are the official ignore files patterns, but lately these major providers of IDEs, they are working together. So AI ignore from JetBrains, they have this disclaimer that you don't need to have an AI ignore specifically if you have the Cursor ignore in your project. And maybe it's also vice versa, and this task is ongoing, but there is no specific single source of truth for all the IDs that can be used. So that's why our project setup has this brain setup initially. And also another thing to mention is the reason for this ignore files is for the exclude the context is that you may have a git ignore file, and this AI ignore files actually use those ignore commands also, but there might be some files that you don't want to, you want to be in your version control, but you don't want to be used by the AIs for context. So that's why these AI ignore files are necessary for your project. Writing rules and these ignore instructions. Here is a very useful online resource that we found during our development was this Cursor directory, where it provides community contributed rules and MCP servers or many other things. So say, for example, if you want to write rules for project, use Next.js, so that and it uses TypeScript, so those are available online. But if you want to develop it for PHP, that can be also available. If you want to develop it for Java, that can be also available, found here. So you can scrape these resources online and fit it to your project as you deem necessary. So rules and ignores, they are the first setup that we have. And then the setup, after the setup is ready, then we move on to the next thing. We still didn't start writing code yet, and that is how we want the AI agents to interact with our code base. For that, what we came up with was dedicated directory AI .ai, and the reason for that is we can use the cursor or Windsurf or the IntelliJ AI assistant directories for those, but those will be IDE specific. But instead, this centralized repository, which we want to be version controlled, is a shared context between our whole team. So the best prompting strategy practices, engineering practices can be shared with our other team members when someone in the down in the line, the future wants to contribute something, so they can know that how to write prompts efficiently. For this, we have a layout of chat prompts, and let me show you from the IDE itself, our project, is that we have this .ai folder and we have this layout here. First is the chat prompts, which will contain some common templates. And the common templates are more like they don't contain any specific description. So, our most of the time our task is to implement a feature. So there is this markdown file, and the reason for using markdown is they are very well recognized by the agents and are able to organize your context very smoothly. So we have these markdown files in our common templates that we want to use to give to our AI agents when necessary. And when we are actually trying to write something in the agent chatbots, we don't want to write them in the chat window itself, but what we want to do is we may want, this is a very small template, just when I was creating the Next.js starter repo, I was using this template, and it just requested the AI agent to create a Next.js project from scratch, keeping in mind the rules, the default scaling. But there might be a very large blob of text required for describing a feature or something else. So at that point, this can come in handy to have it stored in a file and version control it, and also possibly review it with your team. And finally, when it's done, then actually use this to do something. So and another thing, very good thing about cursor is that cursor has this commands pattern. The same goes for Windsurf. So whatever, if there are some generic templates that can be all that you use always to provide to your chat clients, instead of writing them all the time and maybe in different times, you write it differently, but you can store them in cursor commands. And similarly, if there is even if any specific instruction that you need to give here, you can link it here. And the same thing goes for Windsurf. Windsurf has this workflow concept where you actually do it also, and it can also take some arguments. As for the other AI agents, what I found out was that these similar commands does not exist, but what we can do is save our prompts inside prompt library for IntelliJ, and maybe same goes for the other tools. So that is one thing that, sorry. So this prompt library is exactly the same thing as the commands library. So you can use this to do the same thing, storing the prompts. The reason, but this will not be shared in the version control and shared with the team. The main reason for saving these prompts is to actually the same reason that we want to have standardized prompts and do not have scattered practices around the team, but this centralizes the things. So there was the prompts. And the other thing is we don't directly ask the AI to do something always. If it's a big feature or big change, multi-file change, what we do is first generate the plan by AI, and store it in our version control again. The reason for that is we want to review it manually, and the reviewing of the generated plan is actually more quicker than reviewing codes that is generated. So if the review looks good, then we go for the execution later. And generated plans, they are stored here. So this is like an initial plan that was generated when I asked the AI agent to give me an initial project creation plan. So it looked good. So I went on with the execution, and the execution of that now looks pretty smooth, pretty execute plan. And then I will just initial project creation plan. So with this only two things, you don't write anything specific here, but just hit execute, and the agent will do the thing. And another reason for this plan is that you can have the option to generate the plan with a very good model, and then execute it with a smaller token consuming model like the Composer or the IQ models. So next thing is, after providing the AI folder as a context, we that the markdown files are actually context, but what we actually can do is, instead, for some small features or some other things that are not possible using the markdown files, we can connect our IDEs and basic ecosystems with MCP servers. And I have provided some resources here. Probably will have the shared here, but let me just give you a quick look. From GitHub, you can see this GitHub/MCP, which is the official MCP registries. There are official and unofficial both kind of registry here, and you can take a look at which personnels or which community developed those, how to set up those MCP servers. From a cursor point of view, again, from cursor docs, you can have this MCP directory link here, and it provides all the official libraries that has been implemented and supported by Cursor itself. So again, you can configure it for Cursor, for IntelliJ. The configuration might be a little different, but it's more or less the same. For our project, we targeted with 3 MCP servers initially: the Confluence, Atlassian, Jira, which had some extra context there. And instead of fetching the details and putting it inside empty files of our project, we can use the ticket links for that. GitHub MCP Server, the official GitHub MCP Server, can provide you connect for creating PRs or commits, pull requests, and reviews, some other things. But the thing that came mostly to our help was the Figma MCP server, because what Hasnat Bhai displayed, made in Google Stitch, that wasn't the final design. There was a designer involved from our design team, Litu Bhai, and actually the proper Figma design was made before the final development was picked up. So what we did was officially Figma, this is Figma's official MCP server. And the reason I am mentioning this official term is that when you are adding MCP servers, you will find online that there might be non-official MCP servers. Use them with your own discretion and judgment, because there might be security risks when you are using these MCP servers. So better to stick to the official servers. But in perspective from the Figma MCP server, it mentions that there are 2 types of server: the remote server and the desktop server. And remote server is available for all seats and plans. You must have a paid seat at least, or starter. And the desktop server requires a dev seat. What the difference is that when you are using a starter plan, you are very limited to up to 6 tool calls per month. So it will not come to your benefit. So we requested a dev seat from Cephalo, and we were allowed one. After this is available, what you need to do is you have to have you can do it 2 ways, either from the Figma's official Cloud MCP server or using the desktop server. First, let me show you how Cursor does it. From Cursor, you can see this Figma add to Cursor, and if you click on this, if your cursor is open, it will take you here, and it will ask you if you want to install the MCP server. This is the details, and this is Figma's Cloud MCP server links. You just click install, and it's added. It needs authentication, so it will take you to the authentication window. You just need to allow the access and open cursor. It will open cursor back, and it's authenticated, and it will show you that this is the Figma Cloud MCP server, and this provides the 8 list of tools. And these are the available tools and commands. For now, I will not be using the Cloud MCP server provided by Figma, because that will give you latency when you are using the Figma tool. But the better way is to have the Figma desktop application installed and access your resources from there. And from here, you will always see this bottom toolbar panel. And if you have the dev seat allowed to you, you will see that you can enable this dev mode, at which point Figma goes into development mode, providing you more details. And then on the right side panel of inspect, you will see under this MCP server that you can enable the desktop MCP server. When you click on that, it says that the MCP server is enabled at this URL. You can copy this URL, and on cursor, you can go here, add new MCP server. And this UI is a little backdated. What it does is takes you directly to the MCP JSON of cursor. And from there, you can actually add on your own the URL that was provided to you from Figma. And I already have this added here, and this is how it looks. So that's just this simple configuration, and you have the MCP server enabled. So let me enable the Figma desktop MCP, and it again says it has 6 tools and 3 prompts enabled, and it will communicate directly in my local server, so lesser latency. So after having this, let me show you a quick demonstration of how we used Figma in our project. So this is the Figma design file. There are lots of files here. For now, for the demonstration purpose, we'll be just using this first design. That's a login page. From when you click on it, we click on this design, you will be able to copy the link node link. So I have to have that available. And I'm using cursor for demonstration purpose. And here you open the agent, and right now we first want to have a plan inside this AI directory, instead of directly just executing the design or implementing the design. So we want to plan the design using the Figma link. But for this demonstration purpose, I will also attach this plan instruction generalized Figma action. This is again a common template here, and it says that I'm not writing this in the chat window. What I would have write is saved in this MD file beforehand, is from the Figma details link provided. You will fetch the Figma details and analyze the request, and then try to do what is asked of you. You can either implement the design or plan the changes, whatever is requested. And since we are planning a new feature, this generalized feature plan, this will create a common document format. So I will also attach that here. And for it would have sufficed, but for now, what I do is also instruct it as only generate the UI login page plans. So this is a special instruction just for this demonstration purpose. It will not take a lot of time. After that, their cursor has the stream mode, agent, plan, and ask. Ask mode cannot access MCP server. That is one limitation that we have found out. Agent mode can, plan mode can. I will demonstrate a plan mode a little later, but for agent, you can select from, if you turn off auto, you will be able to select models here. One thing that I have observed is cursor composer and composer model is pretty accurate to do the task that is described here. But for larger tasks, you may need to create a Sonnet or Gemini 3 model to generate the plan first. And it will generate a very large plan and also consume a lot of tokens. But cursor composer is actually pretty fast. It does not consume that much token, and it will be able to generate the plan for you. And during execution, it also does the same. So let me just select this one for now and hit execute. Meanwhile, while it's being executed, just let me go to the other link of Figma MCP server, or for Atlassian, it's the Rovo MCP server. Setting up these servers are pretty easy. The details are given here. Most of them use NPX server. For online server, this is also available, mcp.atlassian.com/v1ssc. So if you are able to, if you need to configure this, you just go to cursor here and tools and MCP, and sorry, you can just add them here and they will have, you have them available. Another thing is, before, when you are doing stuff here, you have the option to turn off the MCP servers. It's good to turn them off unless you need them, because it might add extra context that you don't actually want to be passed to the agents. So only have the agent that is required to be present. Okay, so this is being executed, and when it started, this is one of the Figma model, Figma MCP server calls that it did, and another MCP server call get screenshot, and you can see that the screenshot that was provided in this link here is also captured by Figma MCP server. This is the same for all the MCP servers, and then it is making a plan for the login page. This is being saved here, and it also actually it finished. So let us review the plan. So it created a technical plan as requested in this initial project creation plan. After that, there are several UI components suggested here. It is breaking down the components. And for now, we'll just execute the plan because it looks good. It is adhering to the project's rules and libraries that were specified. So if you are sure that you want this plan to be executed, you can just do this and so only the plan is generated here. Now we are executing the plan. Using the same composer model, it will take consume minimal tokens, and it's very fast and accurate. One thing that I have figured is that cursor, when the agent blocks in some place and asks for your permission, it actually does not give you any notification. But in IntelliJ WebStorm, if the agent is stuck somewhere, it will give you a floating notification here. So if you're doing something else, you can come back here and continue the task from there. Another thing is, if you trust the command to be executed, to be safe, you can add that into allow list, and allow list will not ask you to execute the terminal command or whatever before doing that. Okay, one disclaimer before this is finished is that I have tried several agents and several patterns of prompting for Figma MCP server integration. And the thing is, not all the agents do it properly. It fails to fetch the resources from Figma. That is, the icons or the images, those are not properly fetched. Like this is an icon and this is an image, and there is an icon here and here. If it's a text icon, it will try to do it. If it's a vector icon, it will try to do it properly, fetch it properly and save it. But if it's If it's not fetchable icons, icon resource, it will fail. And it will give you a placeholder. So what you need to do is have that manually allocated. So the new page generated is /login. And this is the design page that was generated using Figma. If you try to match it with whatever was inside Figma, you can see that the image was scraped properly. This icon failed because it's not, I think, exportable resource. This text matched, and this font actually also matched. This the border radius seems good. This placeholder looks good. The icon of Microsoft that was disabled grayed here, but it generated a colored icon, and also the alignment of it failed. But this is the very first attempt that it did, and the usage, I think, is not that much from a cursor perspective. It took $0.18. This is the first one that was the planning phase, 0.07, and this is 0.18 for the execution. So this is the output that is provided by the initial try. And the funny thing is, I tried it several times, and there are several outputs. The repository that I previously spoke of, this will, if you go to the branches list, you will see I have provided some examples here. And if you run them, you'll see different outputs from different times. So I used Claude Code. Claude Code on the first attempt, it failed. Actually, it was not able to generate it properly. But on the second attempt, there was a very good output from Claude Code. Let me just switch to the branch. This was Claude Code output. Again, if you can see that the logo was not proper. The Claude Code actually did not grab the font properly. This looks good. And this icon again is colored. The alignment was okay, but this is not actually what we wanted from the Figma design. So most of the code generated is to some extent capable, but then again you need some human interaction, because that is how it is from and we have not provided any design details in textual format. This is just the context that was obtained from the Figma design as it is found by the MCP server. So there are restrictions in the MCP server. Not all the agents actually use the information properly, so definitely. And also the limitation for scraping resources, that is one thing that we can't do anything about for now. Okay, so moving back to our presentation, after the demonstration is that there are some thoughts from our side after using all these AI agents, is that it was very good for rapid prototyping, as Hasnat Bhai previously displayed. If you want to have just the idea converted into a design, it looks good. And as also from the development perspective, when using the cursor composer agent for just converting the design on a time crunch directly to a working web page, is also good. But the other thing is there always will be some human interventions needed, and that is up to you guys how you use it, if you can take it to perfection. And also the agents are always being upgraded. That is one disclaimer. So it's always about how you use these agents. And the reason, one of the main benefits that we found out was that it acts as a pair programmer. The AI agents act as a pair programmer for you. So what happens is that you can do something else. That's something that is more sharing of sorry, there was a hiccup. The sharing went off. What I was saying is that the AI pair programmers can actually help you to do the task from your side, but you have to be as a guide, as a mentor to take out what is actually stuck. Okay, well, there are some hiccups on the presentation slide, which is not being displayed properly. But let me continue from there. Is that we don't need the slides now. Is that you have to be as a guide, as a mentor to the AI programmer. You can do something else, but get back to it when it's giving you the output to finally making it workable for you. So in our project perspective, almost 80% of the final code was generated and kept, but there were some adjustment definitely that was needed from our side. And another thing is these agents, they are always being upgraded. So what is happening is that when I started initially developing it back 2 months ago, the cursor AI agent output that I have displayed was not actually perfect. It was not able to scrape the resources at all. But within these 2 months, definitely there were some upgrades and the output is much more satisfactory now. I have tried it with all three agents of Claude Code, Cursor, Composer, Juni agent from IntelliJ, and they provided better outputs after a few time. The upgrades came and they are better now. And as for the Data Explorer project that Hasnat Bhai was mentioning, let me just show you a quick demonstration of what was built. This is the login page that you have been seeing in Figma. And after the login page, this is the landing page. Also, it was coming from the Figma design, and but the Figma design was pretty good. And this is the new feature that was implemented for Data Explorer. And the design actually changed from what was built in Google Stitch, but now this is the design that was finally put in Figma. And not all of them were actually scraped from Figma. There were some incremental development. So say, for example, this first tab was implemented and some context was taken from Figma, but other context was passed from using the MD markdown files in the AI directory that I mentioned. Textual descriptions were put to talk about the relations. Say, for example, selecting this database, the table will be filtered based on this one or fetched using this information. That is something not possible from the Figma design. So the design is there, but the context that has to be typed in manually and not manually. And you can also use the Jira MCP server to fetch the details for you if that fits your need. But these are the various ways that can be used to pass down the details from Figma for using the MCP server's connectivity power. And if not, just put the AI directory generated chat prompts and whatever you want to do, just put the details here and ask it to execute that for you. Just like this was a whole new details that I had to put in as a textual description for the feature that is displayed for this the generation of this tool. And what the AI did was without even Figma details. Sometimes it actually just from the description, like this is a two column design. There is a left panel, right panel, three drop downs, and with the specific design UI framework in place, it was able to do the task properly without even taking a look at the Figma design. But that is always a good thing to have for rapid time crunch requirement that we have. So last thing before ending this presentation is that from our experience, what we figured out was that for prototyping is good. You are able to leverage the AI to generate a lot of code for you, do the pair programming for you. But after a while, it feels like you are not in the ownership. Like the code is generated by AI, it gives you an error, so you don't want to fix the error. You just want the AI assistants to reiterate it and fix it for you. But there are some exhaustion after some time, like it's not able to do something properly. Then you have to go back and do this yourself. And at that point, you have to understand how the AI wrote the code and what needs to be changed. And sometimes you feel like, oh, this is not something that I would have done if I did it. Then you have to do a refactor by yourself totally. So there is always this mental fight with the AI agentic outputs. But I would say that similar thing happens with every tool that is in its initial phase. And as it matures, if you can actually take leverage of the tool, it can make you smarter and have better output than everything. So with that, I will be ending my speech and leave it up to you guys. Thank you.
All right. So does anybody have any questions at all?
Yes, I want to ask.
Yes.
Hello, this is Abrar. So I would like to ask just a few things, maybe one. So first of all, I have seen that there is some prompts that you're including in Claude MD or any workflow or something like that. So if we command that this prompt should give this prompt should add in every request of our interaction, then it is going to increase our context size, right?
Yes.
So this is significantly consume our token that if we constantly use those, and or the context is too big, right? It's going to burn our tokens. So that's the only disadvantage of using that prompt is too long, right?
Yeah. So those are the rules files that you are talking about, the brain of the AI agents. If you want a rule to be applicable always, then you have to do it. But if you don't want to do it, then you have the discretion of selecting not apply it always, and I will select when to apply. So that way you can control the token consumption.
Right, but did you find that even after applying those rules, the agent is violating when the context or the conversation is too long?
Yeah, definitely. That's why this you use a new chat to open and just pass the necessary action for that session. Like you plan the design in one session and you execute the design in another session. That way the AI will have precise knowledge of what to do.
Right. In my experience, what I have seen that if you just build one or two UI or one or two flow like this, it works. But after a while, if you trust that and go forward, and then it try to disrupt your development or the thing, right? That's what I have seen. So I'm just asking that if you have the same experience or similar kind of pitfall that you have found in the path.
Yeah, actually, the models have a context size. So if the conversation is longer, so when a new conversation is happening or a new message is sending or the responding back, then it try to combine all the conversation and pass it to the model. So when it's a larger than the context size, then it summarize the previous context. So if summarize the previous conversation, then obviously there lose some informations. So that's why the model performs worse and if the conversation is too long. So we have to manage a few conversations in a chat session or something.
Yeah, and adding to that is it's a greedy approach to just reprompt and reprompt again until you get it right. But whenever you see that, it's a red flag that the agent is not behaving properly or will not be able to do it properly. So just take a step back, create the problem check the prompt that you want to give it, and then review the plan that it is generating even before going for the execution. So even after the execution, it might not be proper, but that's a shortage that we have to deal with for now until they just become perfect.
Yeah.
Thanks. Great presentation.
Thanks, bye.
One question, yeah. So we are now seeing how our lives are actually going to be down. We need to be a very good AI prompt writer in our CV in near future, yeah. But the good thing is you have used some very good practices, as you have mentioned some common rules and convention how everyone needs to be followed. But my question is, as you have mentioned that most of your code base are maintained by the agentic AI, so how you actually manage the review processes and the next, I mean, if you evolve the new version or change the new models, how your changes are being affected? Because most of the in your presentation I have seen that most of the JS classes are being generated dynamically. Those actually are not practiced in if you write in manually. You are trying to use some common convention for each project. So how actually you following the workflow? I mean, after generating the code based, how it is being reviewed, or how you are adopting the new features in your REST, because count be more if you have all the logic in the next context. So what will your process you are following for the new features and the review process?
Okay. For the project that was displayed in the demonstration, that is not actually our client's project. It was a starter boilerplate project, and I did not actually utilize it to follow the best practices. But for our project, what we did was lay out a project structure. Client specific requirement was to have this AI assistant set up ready from the beginning, so that in future it can be contributed by anyone else. So what we followed was there was this domain pattern for all the and there was this modular approach. So and the instruction of the project structure was kept in the rules file. So what happened was that it will not just generate random components and place it somewhere else that we don't want to, but we gave specific permission like create a new data explorer module, and inside the module break down the components into these and these instructions has to be provided. It's not just calling the Figma and do whatever you want to do, but the exact instruction has to be provided, and then the plan was generated to see if the coding agent thought properly, and it will generate the proper structure. If we found out that the structure is there, and then we will call it to execute. And even then there will be some human interventions of 20% that we mentioned, is that okay, this file naming I don't like, or this is a file that is generated not required, or this component become very big, we don't want to have it in single place, breakdown in multiple components. And if the task is long, we will again reiterate the AI to do the task. But if it's not, then we just do it manually, because better to save tokens on that portion. So it's not the starter demonstration that you saw definitely was not a production grade thing. For the production one, we actually has a more controlled directory layout and other definitions that we need for TypeScript and conventions to follow. Those are in our project.
Yeah, I also add a thing quickly that we have executed our plans and added features step by step, not all features at once. So if one feature is generated by AI, then we manually test and review. We also have test cases. So AI agent run the test cases. If that is passed, then it said okay, then we review manually. And if we are okay with the review, code review, then we just put in a push into a feature branch, and feature branches go for a merge. And for the reviewer selection, we have two reviewer at least. One is Copilot, another is team lead or any other teammates. And Copilot gives feedbacks. The reviewer took that feedbacks and his own feedbacks. They can use currently we are practicing Claude code review also for a manual review. So we are combining the Claude code review, Copilot review, and our own manual review. Then it merges into dev branch. Then it's for further action or something like that. So this is our review process actually.